Good morning, third graders. Our targets for today are: I can use an area model to represent multiplication facts, and I can multiply 4 by 4 up to 4 times 5, and I can multiply by 3 up to 3 times 5. Yesterday, you learned that a benchmark fact is a fact you know automatically. For example, 2 times 5 equals 10. All of the 10s, 5s, and 2s facts we have learned are benchmark facts for us. We will be working on learning more benchmark facts over the next few days. Let's go ahead and do a little bit of benchmark fact practice. We'll do the first few together, and then you'll complete the rest independently. Let's start with the fact 10 times 3. Think about 10 times 3 and what that means. Well, I know that 10 times 3 means that there are 10 squares in each row times 3 rows. 10 times 3 is 30. Let's think about the fact 10 times 1. 10 times 1 is easy. It means 10 in each row with just one row. 10 times 1 is 10. 10 times 9. Ooh, that's a big fact. That's 10 squares in each row times 9 rows. 10 times 9 is 90. 10 times 5. 10 squares in each row times 5 rows. Oh yes, 10 times 5 is 50. You'll answer the rest of these 10 facts, benchmark facts, independently. Ready? What is 10 times 4? Yes, 10 times 4 is 40. What is 10 times 7? Oh yes, 10 times 7 is 70. What is 10 times 6? Yes, 10 times 6 is 60. What about 10 times 0? Oh yes, 10 times 0 is 0. What about 10 times 8? Yep, 10 times 8 is 80. What about 10 times 10? You're right, 10 times 10 is 100. And finally, 10 times 2. Oh yes, 10 times 2 is 20. Let's go ahead and review some of the vocabulary words we've learned over the last few days. Let's start with the word area. Area is the amount of space covered by an object, the total number of square units. And of course, a square unit is the unit used to measure area. It's a measurement whose sides have exactly the same length. You can see an example of a square unit here. It's 1 unit long and 1 unit wide. It covers an amount of space, and we can use it to determine area. Here you can see we have a rectangle with visible square units. Let's go ahead and count the square units to determine the area. Ready? Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The area of this square, of this rectangle, is 12 square units. That's the amount of space this 4 by 3 rectangle covers. We also know that a side length is one of the sides of a rectangle. Rectangles have horizontal side lengths, sides that run side to side, the top and the bottom, and these tell us how many squares there are per row. Rectangles also have a vertical side length, actually 2 of them, the left side and the right side. These are how many rows there are per rectangle. You know that horizontal means flat, level, running side to side. Here is a horizontal arrow. Here is a vertical arrow. It goes up and down. You've learned that a factor is a number you are multiplying. Factors are the side lengths on a rectangle. One factor is the number of squares in each row, and one factor is the number of rows. This is that same rectangle we looked at just a moment ago and found the area of. You can see that there are 4 squares in each row, That's one side length, 4, and that there are 3 rows. That's the other side length, 3. Both of these numbers, the 4 and the 3, how many squares there are in each row and how many rows there are, become factors in our multiplication equation. 4 times 3. You'll also remember that product is what we call the answer to a multiplication equation. The product is the area. The product is the area of a rectangle. It's the total number of square units that the rectangle covers. In this case, with our 4 by 3 rectangle, our area is 12, so our product is 12. 4 times 3 equals 12. The commutative property of multiplication tells us that changing the order of the factors does not change the product. So, for example, if you look at this 4 by 3 rectangle, we know that there are 4 squares in each row and 3 rows with a total area of 12. So we could say that 4 times 3 equals 12. Well, if we change the order of the factors to 3 times 4, meaning that there are 3 squares in each row and 4 rows, the area does not change. The product does not change. It is still 12. 4 times 3 equals 12, and 3 times 4 equals 12. The commutative property says we can change the order of the factors without changing the product. So let's put it all together. What do we know? We know that each of these are square units. We know that the horizontal side length, or the number of squares per row on this rectangle, is 4. We know that the vertical side length, or the number of rows per rectangle, is 3. So we would say that this is a 4 by 3 rectangle with an area of 12 square units. We also then know that 4 times 3 equals 12, and 3 times 4 equals 12. Awesome job, 3rd grade. Let's go ahead, 3rd grade, and think about some facts we have. Think about some new benchmark facts. We're going to go ahead and start by thinking about 3's facts. I'll take one of these horizontal 3 strips and put it on this grid. Look, I've made a rectangle. Let's go ahead and think. How many groups are there? Well, I can see that there's just one group. And how many squares are in this group? Well, there are clearly 1, 2, 3. 3 squares in the group. So the size of this rectangle is a 3 by 1. The area of this rectangle is 1, 2, 3, 3 squares. So if we know that this is a 3 by 1 rectangle with 3 squares in each row and 1 row, we also know that 3 times 1 equals 3. The commutative, we now know a new benchmark fact. The commutative property of multiplication says that we also know 1 times 3 equals 3, because we can change the order of the factors without changing the product. If I turn this same rectangle on its side, well, I now have a 1 by 3 rectangle, but my area stayed the same. It's still 3. So the commutative property of multiplication tells us that we can change the order of the factors. So if I take this rectangle and turn it on its side, I now have a 1 by 3, but the area didn't change. So I also know that 1 times 3 equals 3. I now know 2 more benchmark facts. 3 times 1 equals 3, and 1 times 3 equals 3. Let's take a look at another fact. I'll take a second one of these strips and I'll turn it on its side. And we now have 2 of these blue strips on our grid. What size? Let's talk about this rectangle. Now there are 2 blue strips even though they're sideways. Let's see how many groups there are. 1, 2, 3. There are 3 groups, and how many squares are in each group? 1, 2. There are 2 squares in each group. So the size of this rectangle is a 2 by 3. What is the area of this rectangle? Count with me. 1, 2, 3, 4, 5, 6. Oh, that makes sense. There used to be 1 blue strip with 3 in it, and the area was 3. Now there are 2 blue strips with 3 in them, and 3 plus 3 is 6, so the area is 6. The area is 6 squares. I now know that 2 times 3 equals 6. The commutative property of multiplication tells us that the commutative property of multiplication tells us we can change the order of these factors. So I can turn this rectangle and make it a 3 by 2. And the area doesn't change. It's still 6. So I also know that 3 times 2 equals 6. That tells me I now know 2 more benchmark facts. 2 times 3 equals 6, and 3 times 2 equals 6. Let's go ahead and add another blue 3 strip. And let's think, how many groups are there? 1, 2, 3. 3 groups. And how many are in each group? 1, 2, 3. 3. So this rectangle is a 3 by 3. Let's find the area of this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. The area of this rectangle is 9. So we now know that 3 times 3 equals 9. I can see that in this case, both of the side lengths on the rectangle are the same. Both of the factors are 3. So it doesn't matter what order. So I can't change the order of these factors. It would still be 3 times 3. We now know a new benchmark fact. 3 times 3 equals 9. Let's go ahead and add another blue 3 strip. Let's see how many groups there are. 1, 2, 3, 4. There are 4 groups. And there are 1, 2, 3 in each group. So this is a 3 by 4 rectangle. Let's find the area together. Get ready. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The area of this rectangle is 12. So we now know that 3 times 4 equals 12. Remember, the commutative property of multiplication tells us that we can change the order of the factors, and it does not change the product. So I can take this rectangle and turn it on its side, so I have a 4 by 3 instead of a 3 by 4, and it does not change the total area. 3 times 4 equals 12, so 4 times 3 also equals 12. We now know 2 more benchmark facts. Let's go ahead and look at just one more. Here, let's take another one of these blue strips, these blue 3 strips. I'll go ahead and turn this on its side. And let's go ahead and think about this rectangle. How many groups are there? 1, 2, 3 groups. And how many are in each group? 1, 2, 3, 4, 5, 5. So this is a 5 by 3 rectangle. What is the area of this rectangle? Get ready to count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This rectangle has an area of 15 square units. So we now know that 5 times 3 equals 15. The commutative property of multiplication tells us that we can change the order of the factors without changing the product. The commutative property of multiplication tells us that we can change the order of the factors without changing the product. So I can take this rectangle and turn it on its side. Now I have a 3 by 5 instead of 5 by 3, but the area didn't change. 5 times 3 equals 15, so 3 times 5 also equals 15. Five by 3 equals 15, so 3 by 5 also equals 15. We now know 2 more benchmark facts. Let's go ahead now and think about some facts. Let's go ahead now and think about some facts with one factor of 4. We'll use this yellow 4 strip. I'll go ahead and put one yellow 4 strip on the grid. How many groups are there? Well, there's clearly one group, and there are 1, 2, 3, 4 squares in each group. So this rectangle is a 4 by 1 rectangle. Let's go ahead and find the area of the rectangle. Well, of course, the area is 4 because there's just one strip. So I now know that 4 times 1 equals 4. The commutative property of multiplication tells us that we can switch the order of the factors without changing the product. So let's go ahead and do that. Let's go ahead and switch the order of the factors to 1 by 4. We know that that also equals 4. So we now know 2 new benchmark facts. 4 times 1 equals 4, and 1 times 4 equals 4. Great. Let's go ahead and add another strip with 4 squares. Now you can see that there are 2 groups with 1, 2, 3, 4 in each group. So this is a 4 by 2 rectangle. Count with me to find the area. 1, 2, 3, 4, 5, 6, 7, 8. The area of this rectangle is 8 squares. So we now know that 4 times 2 equals 8. We also know 2 times 4 equals 8 because the commutative property of multiplication says we can change the order of the factors without changing the area. So we now know 2 more benchmark facts. 4 times 2 equals 8, and 2 times 4 equals 8. Let's go ahead and take a look at another problem. Let's add another 4 strip. Now we have three four strips. So how many groups are there? 1, 2, 3. There are 3 groups with how many in each group? 1, 2, 3, 4. 4 in each group. So this is a 4 by 3 rectangle. Let's count to find the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 squares in all. So we now know that 4 times 3 equals 12. We also know 3 times 4 equals 12 because the commutative property of multiplication tells us we can change the order of the factors without changing the product. So we now know 2 more benchmark facts. 4 times 3 equals 12, and 3 times 4 equals 12. Let's go ahead and add another 4 strip. Now we have 1, 2, 3, 4 groups with 1, 2, 3, 4 in each group. So this is a 4 by 4 rectangle. Let's count to find the area together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 squares in all in this rectangle. So we now know that 4 times 4 equals 16. I can see that in this problem, both of the factors are the same, so I know that changing the order of them won't make a different problem. 4 times 4 equals 16. Let's go ahead and look at just one more 4's fact. Here I'll add another 4 strip. Let's count the groups. 1, 2, 3, 4, 5 groups with 1, 2, 3, 4 in each group. So this is a 4 by 5 rectangle. Get ready to count the area with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The area of this rectangle is 20 square units, so I now know that 4 times 5 equals 20, and also 5 times 4 equals 20. We now know 2 more benchmark facts. Let's go ahead and look at a couple of area models together. Look at this rectangle. Which multiplication fact matches this area model? We'll do this one together. I can see that this rectangle area model has 4 squares in each row with 3 rows. So this is a 4 by 3 rectangle. What is the area of this product? Well, I could count the squares of this 4 by 3 rectangle to find the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 times 3 equals 12. You're going to do the next 4 independently. Get ready. What multiplication fact matches this area model? You're right. This is a 3 by 3 rectangle because there are 3 squares in each row and 3 rows. What is the product of 3 times 3? You're right. 3 times 3 equals 9. Look at this next problem. What multiplication fact matches this area model? Absolutely. This rectangle has 4 squares in each row and 4 rows, so it's a 4 by 4 rectangle. What is the product of 4 times 4? You're right. 4 times 4 equals 16. Let's look at another one. Which multiplication fact matches this area model? Absolutely. This is a 3 by 4 rectangle, so 3 times 4 is the multiplication fact that matches this model. What does 3 times 4 equal? Yes, 3 times 4 equals 12. And finally, look at this area model. Which multiplication fact matches this area model? You're right, this is a 1 by 3 rectangle. What does 1 times 3 equal? Absolutely, 1 times 3 equals 3. Thank you for learning these new multiplication benchmark facts with me. I'll see you again tomorrow.